Hi, this is Dave Shook. Welcome to the next in a series of videos. I want to talk a little bit about operational technology data ingestion to the cloud, basically some of the whys and wherefores. Now, up to now, we've primarily been talking about the data path for data coming from like a controller through a DMZ and then up to a business network, but there's also systems that communicate directly to the cloud. Um, so let's first talk about why we want to move data to the cloud in the first place. So there's a number of different reasons. The first one is you can lose the data if you don't keep it. A lot of data pertaining to, say, configuration information, so changes in the configuration of the control system, or for that matter, in the instrument data itself, that information only has a finite lifetime down here. You may want for compliance or long-term performance reasons to hold on to that data for a long period of time. And it can be very inexpensive to retain data for the long term in the cloud. Um, Secondly, the cloud is a very useful place to combine data from multiple sources because you don't have to worry about networking among the different systems because that's all been brought the data's all been brought up to the cloud. Also, some data from third-party systems like vibration monitoring systems often ends up in the cloud to begin with. Basically, it's transmitted directly from those systems through a cell or direct network connection to a vendor's cloud location, and so that data is already like cloud resident. Another reason for bringing data up to the cloud is if you need lots of compute. Um, Computation on site is owned, it's a capital asset, which means that it is constrained. So if you want to run a high computational load job like simulation of an oil reservoir over a period of years using seismic data, you will need lots and lots of computers to do that, or you will need a very long time in order to do that. In the cloud, you can in effect rent those CPUs for when you need them. Um, and then, finally, there are some services that are only available online. Certain analytic, AI, ML, or other services are really only available online. So in that case, you got to get the data up to the cloud just to be able to use those services. So the next question is, do you bring it up in your real time or do you bring it up in a batch mechanism? Now, near real time data is can be extremely useful. That's the sort of streaming data use case. And that's the case where as data is created in here, we read it rapidly from our data acquisition client and push it up to the cloud so it can be analyzed with a low latency. So say streaming, so let's say it's sub 1 minute from source to the cloud. That can be very effective if you're looking to do high speed analytics. But industrially, most analytics that have to run that fast, once they're in production, tend to run down here in the DMZ or even down in the control system itself. So the value of bringing streaming data up to the cloud in an industrial environment kind of depends on the use case. There's also a downside to streaming data, which is that in many cases, when we're acquiring data from something like a historian, if we're bringing data in, the most recent data on a sort of once a minute sort of basis or less, it is possible for that historian to receive updates of data that is old. So data that took longer than usual to get to it. And in that case, it may not show up in the streaming data set, depending on the problems with the architecture and design of that particular system. So batch data transfer uh, is done typically at longer intervals, but has a better chance of delivering a complete data set. Practically speaking, you tend to need both streaming and batch for industrial data acquisition to the cloud. Now, um, moving on, a little bit about how you acquire this data. So there's several different protocols that are in use. One of which is called MQTT, which is a data transport protocol. It is relatively lightweight, which means to say that it doesn't use a lot of CPU. It's not hard to program. It does not impose a very heavy burden on the network. In contrast, OPC is much heavier, but contains a lot more information about the source system. So we can think of this as more complete. Now, they are used in different domains. OPC is used extensively in an environment where you have got good networks, decent power out in the field, and intelligent machines. So you've got power, both electrical computing and robust networks. MQTT tends to be used in the process industry SCADA world as well. So there are strengths and weaknesses to both protocols, um, but they are two of the most common that are used. There's also another one called AMQP, which really was extensively used in banking, probably still is, but never really caught on in the industrial IoT space. And then there's a number of proprietary ones. They are quite honestly pretty good fit for purpose, but the problem always is interoperability with proprietary ones. So, last little bit, why not move data up to the cloud? We've talked about the security issues, about opening up the possible vectors of attack to the operational environment when you're moving data out to the cloud. The security argument is actually pretty well managed. So it's less about security, it's more about cost these days. Now, if we think about the computing that happens down here, what's going on here is we have high frequency data, so multiple values a second. We have low compute latency, so multiple calculations a second. And we also have significant uh, consequences of failure. And we can see that these three dimensions really determine where you want to put compute. If as you move further to the right, and this really gets into what's called the Purdue reference model, which I encourage you to look up, although its original form is a very old document reference model. Uh, it really says that as you move further away from the instrument, the time span around which you're making a decision increases, but the scope of the decision increases. So you start with down here, you're dealing with one instrument and milliseconds. As you come up to higher and higher levels, you go to broader and broader scopes and longer cycles. So up here, the data in the cloud should primarily be used for either building and configuring the calculations that are going to run on premise or for helping people deal with integrated data for decision making so that people can make those decisions. Okay, I hope you found this useful and interesting. Please feel free to follow us at uptakefusion.com or contact us at uptakefusion.com if you have any questions. Thank you. Have a good day.